Good afternoon, everyone. Wow, so many friendly faces. Okay, let's begin. Uh, my name is Roman Axelrod. I happen to be a tech entrepreneur, a serial founder of tech companies, and so far I have 3 exits under the belt. For the last 3 years, I've been on a new, very exciting path to the largest goal possible, to develop the next generation of computers. To make this vision a reality, we, together with my co-founder Valentyn, we have founded a company called Expansio. By now, there are about 50 of us. We are based in our emerging technology research center in Dubai. We have developed a set of prototypes of smart contact lenses bearing digital functionality. So things we're talking about today is not a concept, is not a slide. We do have working prototypes, and you all are very welcome to join us at our booth to check them out. We have been incredibly lucky to be ranked among it indicates top 5, but actually it's already top 3 research institutions in the UAE among all types of science, and we appear to be a top 5 optics labs worldwide. This all allowed us to raise a very substantial amount of money. So far, we have raised $40 million as a seed round. But how did it happen? That's me, 4 years old probably. Like many children, I dreamed of becoming an astronaut. I spent long hours gazing at the stars and building makeshift rockets out of cardboard boxes. Well, however, as life often goes, life took me a different path. I became an entrepreneur, a tech entrepreneur, but still I do hope to contribute to one of the largest goals possible humanity has set itself for the century in a different way. Humanity seriously plans to become an interplanetary species. We are aiming at colonizing distant planets within 15 years. And it's not, when I say plan, I don't mean some crazy people bragging about it. The nearest programs, they aim to send people on the moon by 2026. And Elon Musk even promises to deliver people on Mars before the end of this decade. And 2030s, they will inevitably bring even more incredible destinations. But look, for real, are we ready to become interplanetary species? Types of fuel, advancements in spacecraft, robots exploring asteroids, certainly pushing us closer to this goal. But still, we're not. We're not because of technological limitations. This is an actual photo from a space station. Today, astronauts still rely on computers, tablets, and, ladies and gentlemen, as you can see, many wires, like many wires. For successful space travel, for colonization of new planets, for sending people en masse, we need a next generation of computing. We did our homework. We interviewed a bunch of astronauts. We did a very substantial customer development. And they explained us that during spacewalks, Astronauts still receive information verbally. Can you imagine that? Like turn left, turn right. And within the spacecraft, as they perform any kinds of tasks, they need to preserve checklists and instructions. They have those checklists and instructions on tablets. And since they have to operate with their hands, they often tend to control those tablets with their noses. Can you imagine that? It's insane, it's wacko. Apart from that, there are many health challenges that have to be resolved with computers. I'm talking about microgravity, radiation, muscle atrophy. All those have to be addressed. And, well, in the end of the day, it would be great not to go mad. Imagine 8 years on a spacecraft, almost alone. We have to have a very reliable computer that will surround people, that will assist people during the flight to help maintain their mental health, their physical form, and to get the tasks done. So, of course, spacecraft will continue to improve. New methods to combat microgravity will emerge. However, as long as we do have this generation of computing, laptop, tablets, etc., 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 space travel will not become truly accessible to the masses, and we're talking about masses here. We cannot become interplanetary species if we are limited by old gadgets. Me personally, I need at least 5 computers just to survive a day. Laptop, tablet, smartwatches, smartphone, PS5, probably Steam Deck. One person, one day, crazy. And we at Xpansio, we truly believe that the next generation of computing, the best interface you can imagine is a smart contact lens. Imagine a computer that is absolutely, well, as we say, best device is no device. Basically, no device, but still, it will allow you to communicate effortlessly, to send all the information and data and money and anything you can imagine. It will allow you, just imagine the ability to have an infinite screen, to put WhatsApp here, YouTube here, I don't know, anything else you'd like to use, and to walk instantly throughout those, to use all your information, all your data, all your apps and software simultaneously in one infinite screen. Imagine a gadget that will allow you to control heart rate, cortisol, IOP level, other important health things. Imagine a gadget that will literally surround you by a very relevant information, relevant information of whether you're feeling down, whether you need to exercise, that will just tell you where to do your tasks and how to perform them. But as I tell this, you might be thinking, great, well, guys, Roman, thank you for summarizing Star Trek, basically. But, well, let's leave Elon Musk department and go back to Earth. And what about something more realistic? The truth is that most of the technologies needed for this are already here. As we say, doing deep tech today is like doing internet in late 80s. It's already here. We just need smart and ambitious people to develop it. And I was incredibly lucky 3 years ago to persuade one of the world's most well-known scientists in nanophotonics and advanced materials, Mr. Valentyn Volkov, who currently is my co-founder, my friend, and CTO of the company. And I would like to, basically my job is to properly introduce Valentyn. And I would like to welcome you on stage so he would tell you more about how exactly we developed this gadget. Thank you.
Thank you, Roman, very much for kind introduction. My name is Valentyn. Indeed, I am, well, by the first profession, I'm academician. I spent like, I don't know, more than 20 years in different universities and research centers all around the Europe, specializing in advanced optical materials, optical sciences, photonics, optics, and so on. So today, indeed, I'm going to show you some prototypes. I'm not going to jump into the deep technical details, so we will kind of I will try to deliver the basic idea and to show that indeed many of the things that we can see in science fictions, sci-fi movies are already reachable and available at least in the labs. Yes, contact lens and how this can be actually related to the space exploring. In fact, wearing contact lens in space and not a science fiction. Actually, according to statistics, almost like 80% of astronauts use contact lens on everyday basis. There is an explanation for that. Roman mentioned those harsh environment conditions in space, like, of course, first of all, it's microgravity, so being away from big sterile objects like our Earth actually influence significantly our bodies, especially our liquids inside head, inside eyes, and it's all actually influence significantly interocular pressure. So actually the astronauts these days are obligatory supposed to use, at least to sleep, with scleral contact lens. So scleral contact lens, it's a rigid ones, you know, they're actually placed on sclera. So it's a wide area of the eye. And it's a bit different from most popular soft ones that we use on Earth. Actually, at Spencer, we are working with both, with soft contact lens, with rigid scleral contact lens, and the technology that we develop actually are easily applicable to both cases. Yeah. So what gives us this belief that we can actually solve the problem of creating this smart contact lens? And our specialization in novel materials and advanced optics and photonics, that's the answer to this question. So today I will actually briefly discuss how those scientific advances can be used for creating practical space application cases, user cases. So let's start with neural interfaces. It's a very hot topic now. So in principle, brain-computer interface allow you to control device with the power of your thought. Basically, it's kind of like a modern variation of telepathy to some extent. So it's not, again, science fiction. As you know, several companies, the most famous one, Neuralink, they already demonstrated that in principle, it's doable. People suffering from paralysis can actually control computers just with signals from the brain. So what about smart contact lens? Can you do something like that by using contact lens? You know, they say that the eye is the mirror of the soul. It's maybe because retina by I mean, from the ontogenetic point of view, it's a part of the brain itself. So it seems like the usage of eye is the most direct way of actually doing neural interfacing. So what we actually trying to do here, we put neural interfaces directly onto the lens. So it's everything what you need to control outstanding devices is actually integrated into contact lens. I would say from this point of view, contact lens is probably one of the most natural way to connect the brain to the machines. So actually, of course, you can directly try to do a neural interfacing through the eye, but actually it's even easier to do it in the intermediate way. So we try to decode the signals from the muscle through the eye. And then we use this as a way to manipulate or control the action of our contact lenses, our smart contact lenses. So what we actually present here, we present a hands-free novel approach of using your tongue. So we are trying to decode the movements of the tongue and to use it to manipulate with the contact lens. And by manipulating contact lens, you can, of course, manipulate surrounding devices around you. So we actually managed to show that this approach can really work. I mean, can be seen. So we use like 5 healthy volunteers for experiments and showed that this approach is visible. All the movements of the tongue, like up, down, left, right, down, were clearly visible for high and low frequencies. Actually, we achieved like 85 accuracy in detecting tongue movements up, down, left, right. And I truly believe that in the future, actually, astronauts will use a tongue exactly in the same way as we use now fingers for controlling smart devices. Why not, actually? Another example, it's biosensing. So the contact lens is a perfect platform for integrating biosensors. So these days we actually use, of course, lots of wearables like those fitness trackers and many others. So they are all placed in our hands, which is actually not the best position for the sensor in terms of achieving the maximum sensitivity. So the lens, from this point of view, actually offers a unique possibility to achieve a superior sensitivity. We developed a bunch of prototypes in our lab. Some of them, they're still presented in the form of lab prototypes. Others, they already exist in the form factor of contact lens. So let me first talk a bit about biosensors, biochemical biosensors. So our approach is to use two-dimensional materials which allow to achieve ultra-sensitive sensors for glucose, single molecular detections, viruses detections, and many other possible applications. Two-dimensional materials already a well-known area. There are some issues which should be addressed if you would like to use them for optochemical sensors. First of all, you have to deal with the low efficiency of two-dimensional materials in terms of interaction of those materials with light. So what we did, we actually managed to combine two-dimensional materials with a smart Fabry-Perot resonator based on standard silicon dioxide substrates, which allowed us to significantly increase a phase sensitivity. Basically, we managed to create a very sensitive biosensor, which actually absolutely superior in comparison with those sensors that now available on the market. So it's actually the most superior and the most sensitive biochemical sensors available right now in the lab. So it's robust, it's scalable, it's very cheap and easy to use and very stable. These kind of sensors can be used to detect viruses, can be detect glucose level, monitor glucose level, cortisol level, many other biochemical applications. Another solution that we offer is optomechanical interocular pressure sensors. As Roman mentioned, interocular pressure is one of the serious and most problematic parameters for spacemen. So microgravitation actually destructively influence our ability to see, especially in a long time period. So what we actually offer, interesting and very sensitive optomechanical system, which can be easily integrated into scleral lens and allow you to monitor your interocular pressure on the real-time and everyday basis. So we actually showed that our solution is characterized by absolutely superior sensitivity, and it's like 50% more effective than standard solutions available now on the market. So, and of course, this is not the only solution that we offer for biochemical solutions. In fact, our contact lens, it's a unique approach. Actually, it's like universal platform. It's like your own biochemical lab on lens, which you always with you and always monitor the parameters of your body. And then, of course, last but not least, I would like to say a few words about augmented reality features, which are available with contact lens, smart contact lens. So that's a typical arrangement how our eye works. So we are very good in looking at the objects which are far away from us. So the light comes from the object going through the cornea and the eye lens, and then it's produce an image at our retina. So what happens if we start to move the object? Actually, the eye starts to adapt. The problem starts once your object is very close to your eye. So at a certain moment, your eye lens is out of the adaptation ability, and you're actually not able to see. So that's the problem. If you would like to integrate the light source, let's say, or micro display directly inside the contact lens, in principle, it will be difficult to see. Well, under the usual conditions, you will not be able to see the augmented reality feature at all. So there are several possibilities how you can deal with that problem. We're actually developing both of them. It's an integrated microprojection and the holographical microprojections. Each of them, they have their advantages and disadvantages, and we are developing both of those approaches in our lab. So the idea of microprojector, you would actually need smart collimator systems, which will allow the light from your micro display to be collimated and then actually produce augmented reality image at your retina. So the problem is that with the use of traditional approach, you can actually achieve it because traditional optical systems, they are too bulky, they are diffraction limited. So what we actually use advanced optical materials, which actually allow us to shrink significantly to hundreds of microns dimensions of our microprojector system, which actually works pretty well. Here you can see some typical examples of our microprojector system integrated inside the lens. So another approach which actually allow you to overcome this problem is to use the holography. So holographical approach is a bit different. It's actually ability to collect all the information about light by the interference process. So then you can actually use opposite procedure, and you can actually restore the recorded information. It's actually allow you to work both with dynamic and static images. If you do everything correctly, then actually you can do a real 3D imaging with a holographic approach. So again, that's another prototype which works pretty well in our lab. Actually, I would recommend to come to our booth, and you will have a chance to experience the work of this holographic projector in a real time. So with this, I would like to say that creating a smart contact lens, it's not a simple task at all. And I would say to some extent it's similar to building a spaceship. But nevertheless, seems like it's doable. And I have no doubt that the smart contact lens would be the technology which revolutionize the space exploration in the near future. So thank you very much for your attention, and see you at our booth at S3 here. Thank you.